The same sum let us solve. Let us solve the same sum. What is that sum? We have to find the current through 6 ohm. By using superposition theorem, find current through 6 ohm. The question is, by using superposition theorem, find current through 6 ohm. I 6 ohm equal to what? The superposition theorem states that in a linear network containing more than one independent energy sources, the overall response in any branch is equal to the sum of responses due to each independent source acting one at a time with all other ideal independent sources set equal to 0. So here, what is response? Response means I am connecting a battery across a resistor. The response means the current through the resistor is called a response. I am connecting a battery across some 2-3 resistances. The response in each resistor is voltage across the resistor as well as current through the resistor. Both are called responses. Or power dissipated in the resistor also can be called as responses. But if you know voltage and current, you can find power. That's why no need to mention power. So if anything you can, what is response? Current or voltage across the resistance in a network, that is called response. So if you want to find the response, suppose 2 or more sources are there, means we have to consider one source at a time, find the response. Then consider the other source, find the response. Add these two together, you will get the total response. If 2 sources are there, what is the net response? Here, 5-volt source is there. 5-volt source is there. 6-volt source also there. That's why you have to find what is the response, what is the current through 6 ohm due to 5-volt source. Then we have to find what is the current because of 6-volt source. Then add these two together. The answer must be 0.046 or point. Statement must be like that. Here it must be like that, but I didn't mention non-ideal source. In some books, if you see, it will be written like that. Containing one or more than independent energy sources, non-ideal energy sources. Sometimes they will write like that. So if it is ideal source, it is not applicable. For example, I will tell you an example. Ideal source. The same circuit I am modifying this way. (5-volt, 6-volt). This 5-volt and 6-volt are called ideal sources. Why? Why ideal? This 5-volt and 6-volt are called ideal sources. Ideal source. What is ideal? Yes, very good, very good. Very good. Yes, yes. The battery source, sit down. The battery source doesn't have any resistance. It means, suppose you are having a small battery. To understand, I am telling this. You are having a small battery. Its voltage is 1.2. 1.2. You are short circuiting. Plus and minus. What is the current through? Theoretically, what is the current? Resistance equal to 0. Suppose you are 2-volt battery, you are short circuiting plus and minus. What should be the current? 2 divided by resistance. Resistance equal to 0. 2 divided by 0, how much? Infinity. If infinity current goes through that, you cannot touch that wire, even though it is 2-volt. Because our body is sensitive to current, not voltage. not voltage. Our body is sensitive to current, not voltage. So if large current, infinite current, can that battery can give infinite current? No, it's not at all possible. There is a limit by that battery. That the limit is given by its internal resistance. As she mentioned, the battery has some internal resistance. Say 0.5. Its internal resistance is 0.5. That resistance is in C. Suppose I'm having a battery. This example, let us see. I'm having this battery. Internal resistance must be mentioned in series with the battery. So battery is this. Internal resistance will be inside. Am I correct? Internal resistance means it will be inside. Inside, you are taking terminal like this. You are short circuiting. But anyhow, the internal resistance of 0.5 will be in series with the circuit. Already I told in the previous example that the resistance may be anywhere in the path. The same effect. If it is inside or outside, same effect. That is, we have seen in the KCL. It may be anywhere in the path. So this and this are same. I am taking ideal battery, has no internal resistance. I am putting that resistance outside 0.5 ohm. What is the current through this? 2 divided by 0.5. How much? 4 ampere. 4 ampere. Here, you are short circuiting means 2 volt divided by 0.5 equal to 4 ampere. It can give a maximum of 4 ampere only. Even you short circuit it. That is called internal resistance of the battery. Here, what is the internal resistance of the battery? 0. Here, internal resistance of the battery, 0. That's why it can give infinite current. The superposition theorem is not applicable for ideal voltage sources. Not applicable. Not applicable for ideal voltage sources. Whether I used the word not, it is not applicable for ideal voltage sources. Here, this 5 ohm can be taken as internal resistance of the battery because it is in series with that battery. Here, the 7 ohm is in series with that 6 volt battery. That's why we can assume that it is internal resistance of the battery. So theoretically, we are not talking about all those things. So if there is, suppose superposition theorem is asked, no resistance is in series with the source, means you cannot solve that sum by using that superposition principle. Okay. Anyhow, suppose, let us try to solve this. What happens? We'll try. This is to understand superposition principle. While considering, we have to consider each voltage source separately. That is the statement you just wrote. We have to consider 6 ohm. We are not solving the actual sum. We are solving the wrong sum. Okay. 5 volt series with the 6 ohm. I am considering only 5 volt. I am replacing the 6 volt by its internal impedance. What is the internal impedance? 0. That's why I have to short circuit. What is the current through 6 ohm? What is the current through 6 ohm? If you want to go, please go. I have to complete this, What is the current through 6 ohm? 0. Current through 6 ohm is 0 because current always prefers short circuit path. Always prefers lowest resistance. That's why entire current will go through, infinite current will go through this. That's why current through 6 ohm is 0 ampere. Now consider the second case. That also you are replacing by internal impedance. 6 ohm. You are taking this 6 volt. I put in the other way. This is 6 volt. I have to extend this. Okay. So here also the entire current is passing through this. That's why current through 6 ohm is 0. Add these two together. How much total current? 0 ampere. So we cannot solve for ideal sources. We'll see in the next class.